A psychologist is interested in whether the community a person lives in is related to that person's opinion on an upcoming ballot initiative. The psychologist surveys 83 people by phone with the results shown below. Is opinion related to community at the 0.05 level of significance? Complete parts A and B. Okay, so the null and research hypothesis are going to be what here? Let's read through all these. Okay, so this first one is the only one that sort of makes sense here. The null is that they are independent. It will always be the null for the chi-square test for independence. So we assume that they are independent unless there's evidence that shows that they're not independent. So that's what the research hypothesis is. Okay, so the cut scores, and we'll do both cut score method and p-value method here. So let's look at the cut scores. Okay, we're looking at 0.05 level of significance. Now recall what DF is. So for degrees of freedom for these contingency tables, you take the number of rows minus 1 times the number of columns minus 1. So in this case, we have 3 rows and 3 columns, right? So it's going to be 3 minus 1, which is 2, times 3 minus 1, which is 2. So 2 times 2 is 4. So here is our DF, and we are looking at 9.488. So if our chi-square statistic is beyond that, if it's bigger than 9.488, we would reject. So we're going to run a chi-square test here using StatCrunch. We're not going to do it by hand. If you clicked view an example, you're probably going to see a by hand approach. We are not going to do that. So we'll click our open in StatCrunch button. And so chi-square test for independence, we're going to go to stat. And then let's go to tables, contingency, and we have summary data. Okay, so our columns are going to be the communities, right? So community A, B, and C. And the row labels are in the opinion, the for, against, and no opinion. And it often asks for this Kramer's test, so I'm going to select the chi-square test for independence, hold down Control key, and then select Kramer's v-test. And press compute, and there we are. So notice it went ahead and helped us out and gave us our total row and column here. Here's our chi-square test. Notice the DF is 4. Here's our chi-square statistic. In this case, 3 decimal places, so 3.687. So now, are we going to reject or fail to reject? That's a pretty small chi-square test statistic. This is unlike the t statistic or the z statistic, right? Doesn't really mean the same thing because of the way the chi-square test looks. So our p-value here is 0.45. That's a pretty high p-value, right? So we're looking at 0.05. So if p is low, we reject HO. But p is not very low. I mean, a result this extreme could occur 45 out of 100 samples. That's not very extreme. That's almost half. So let me show you again what this looks like visually. So I can go to Stat and Calculators and select chi-square. Okay, so our DF was 4. And we're going to be going greater than, what do we get for our chi-square statistic? 3.687. There's our 0.45. So very likely this to have occurred just from random chance alone, right? So this is why we reject. So what was our cut score? So if I put in 0.05 here, it should be pretty close to 9.488. And it is 9.488. That's 0.05. So if we hit in here, that would be very unlikely, right? And if I had a value, let's say my chi-square statistic were 10. So that's, the likelihood of that happening is 0.04. And again, it's in the rejection region. So hopefully you're starting to make these connections between these values. So let's see. So we're not going to reject. The study is inconclusive, or we don't reject the null hypothesis. We cannot assume that they are not independent. Okay, and we haven't talked a lot about effect size in here. It is that phi value which I computed, the Kramer value. So that Kramer value is 0.15. So is that a high value, a low value? They're giving you a table here to crunch this out. And we just sort of see where does one, we have a df of, so we're looking at that df, we have smallest side is 3, so we're looking at this row right here, and we're at 0.15. So it is not, if it had gone over to like the point, if the phi were 0.21 or above, it would be medium. If it were 0.35 and above, it would be large. So it's still in this small range here. So I hope that helps.